them a lot today. So let's get our calculators out. And let's just type these in and see what we get. Now, what's the big thing we have to remember? Talked about it yesterday or the day before. Yeah, you got to pay attention to what mode you're in, because you can press all the right buttons, Harry Payton. You can press all the right buttons, but if you don't have your calculator in the right mode, it's not going to work. So this is a radian measure right here, so I'll make sure my calculator is set in radians. It is. Now, how do I put a secant in? 1 over cosine. So I literally type on my calculator 1 divided by cosine 18 pi over 7. So 1 divided by cosine, the parentheses come in automatically on most of your calculators. If not, you have to put them in, but I think most of them they come in automatically. 18 pi divided by 7. And who got an answer for us? Delaney?
I got -4.4939.
Yep, that's right. That's what you should have come up with. And when you're asked to do this for a grade, there'll be rounding instructions. Right now, I just want to make sure everybody's getting that number. Okay? Now we look at this one. Uh-oh, this one is in degrees. So I'll go back to mode, switch over to degrees. Now we type in tangent 53, then we go into our angle menu, remember, and get the degree mark. And then we type 18 and go back into our angle menu and get the minute mark. And who got an answer to this one? Yep, there we go. Right? And then finally, one more. This one's in degrees. We're already in degrees, so we're good to go. How do I get a cosecant on my calculator? 1 divided by sine. So 1 divided by sine, 38. Go into your angle menu, get your degree mark. 10 in your angle menu to get the minute mark. And it's 1.61825. So everybody's okay with that. So if I gave you a half-sheet quiz one day and said type these in on your calculator, everybody get them all right. Okay, then let's look at some applications of this skill. I mean, we don't just type stuff into our calculator for the fun of it. There's a reason we do that. And it's to help us find parts of triangles. Now you can say to me, how come I would ever want to know how long that side of that triangle is? Well, think about this situation for a second. Suppose there's something up here in the top of a tree or at the top of a building, and you're standing out here and you'd like to know how far away you are from that thing. Your friend up at the top of the building or a bird in the top of a tree. You can find that distance without measuring it. You can find that distance using trigonometry, can't you? Let's look at that situation. It's a right triangle. So I'm going to think about SOHCAHTOA.
That's right.
Here's the angle I know I'm going to use. Which side is this? Relative to this angle, is this opposite, adjacent, or hypotenuse? That's adjacent. Which side is this? That tells me which function I'm going to use, right? The two sides involved in the problem are adjacent and hypotenuse. So I am going to use which function? Cosine 39 equals adjacent over hypotenuse. The cosine of this angle equals the adjacent side over the hypotenuse. So x cosine 39 equals 23. And x equals 23 divided by the cosine of 39. So we can find out that side.
Is this radians or degrees?
general rule is if there's no mark on the angle, it's supposed to be in radians. I did mark that one, I just wasn't marking it. I came up with 29.6. Did you? So you just found a side of a triangle. You're going to be doing a lot of that in the next few weeks. Oh, here's another one. All right, let's figure out how we're going to find this side of the triangle. If we use this angle, and why wouldn't we? It's given to us. So, makes sense, you know, kind of easy to use that one. If we use this angle, which function are we going to be using? Sine, cosine, or tangent? Take a look here. Sine? Why would we use sine? You're right, why would we use sine? Because relative to the angle, we have the opposite side and the hypotenuse. So we'll say sine 53 equals x over 10. So x equals 10 sine 53. And did you get 7.98, so 7.99? Did you get that? Pretty easy. Okay, so let's ramp it up just a tad. Suppose the direction said, solve triangle ABC. And you were told that A is 52 degrees, C is 90 degrees, and A is 6. Now, first of all, let's just talk about what all this means. You may have never seen a problem expressed this way before. Solve triangle ABC means find everything. A triangle has 3 sides and 3 angles. So by the time we're done, you got to have it all. If you're solving a triangle, you need to know all 3 sides, all 3 angles. Anytime you solve a triangle, you'll be given 3 pieces of information. This goes back to geometry. Remember when you were proving triangles congruent? Look, we got some on the board over here. When you were proving triangles congruent, remember using SSS and SAS? How many letters are there in all those things? 3. You have to have 3 things to make a unique triangle. So I have given you 3 pieces of information here. So I'm going to draw a picture of this. I'm going to call this triangle ABC. And it's a right triangle. Now that isn't going to last much longer. At some point soon, we'll be looking at all triangles, not just right triangles. But for now, we're studying right triangles. So angle C is 90. All right, angle A is 52. Now, side A, the big letters refer to angles. The little letters refer to sides. And side A is opposite angle A. So this is side A over here. And this would be side C, and this would be side B. Capital letters are the angles, small letters are the sides, and the sides are labeled across from their angles. Got it? So what do you have to figure out in this problem? What's left for you to figure out? You need side B, side C, and angle B. Now angle B is a no-brainer, isn't it?
Yeah.
What do we know about the angles of a triangle? They add up to 180. So if you know 2 of the angles, the third one will be easy. So we will know that angle B, this is what I still need to find. I know that angle B will be what? 38 degrees. Now it doesn't matter which side you find first, you just have to pick one and find it. So which side do you want to find? B. All right, you want to find side B. You can use either angle, but you got to pick one to use because you're going to have to use the 6 right here. And what are you going to need to know about the 6? Is it going to be the opposite side or the adjacent side, right? Depends which angle you pick. So do you want to use 38?
No.
If we use 38, and you can use whichever one you want, it doesn't matter, but if we use 38, then B would be the opposite, and 6 would be the adjacent. So if you choose to use angle 38, you'll say tan 38 equals B over 6. Is that a true sentence? Yes. Are there other sentences you could write? Absolutely. You just have to decide. Pick and go. So what's B going to equal? B is going to equal 6 tan 38. So I got 4.69. Did you?
Yeah.
Now I want to talk just briefly, because this will matter in some future problems. Does it make sense to you that that would be 4.69 compared to this side being 6? Why does that make sense? Exactly, because the angle's smaller. It's called the Hinge Theorem in geometry. The bigger the angle, the bigger the side. So if 52 goes with 6, then whatever 38 goes with is going to have to be less than 6, right? Okay. Now, what about C? How do you want to find side C? We got to be careful. The Pythagorean theorem is an option. Why am I a little hesitant, though? Does anyone have an idea why I'm hesitant? Because this is a rounded off answer. Now, if you want to use what's on your screen right now and not round it off, just use that number, that's okay. But what's another option we have? Pick a different function, yeah. If I were going to do 38, I probably wouldn't do sine. I'd use cosine probably, so that I didn't have to use this rounded off. But if I use 52, I could do sine. So it's up to you. I'm going to stick with 38, and I'm going to say cosine 38 equals 6 over C. I feel like we've talked about a lot of different concepts. Are you following along here? Are you keeping up with this? So C cosine 38 equals 6, and C equals 6 over cosine 38. Which is 7.61. Does that make sense? Well, yeah, it's the hypotenuse. Doesn't it have to be longer than everything else? Everybody okay with that? All right, let's try another one. Let's solve this triangle. All right, here we go. What's this look like? Let's draw a picture of it. Everybody okay with my labeling? So what are we looking for this time? Side D, angle E, and angle F? Any of those look easy? Jessica?
Well, I have a question.
Uh-huh.
If when we're told to solve a triangle and we aren't given one of the angles is equal to 90, how do we make sure we draw it right and label it right?
You know, it doesn't make a bit of difference how you draw it, because the figure isn't what's important. What's important is that wherever you put your angle E, side E is across from it. It will not matter in terms of your picture at all. And in that situation, I erased it, but we won't be using SOHCAHTOA because you can only use SOHCAHTOA in a right triangle. So we got a couple of other tricks up our sleeve that we'll have to use in that situation. You can get side D quite easily using the Pythagorean theorem. So that we can do. So D squared will equal 121 plus 100. So 221, D is going to be the square root of 221. Would you agree with that? So I'm just going to leave it that. If I have to type it in and round it off, I guess I can. 14.87. Oh boy, now what? Actually talked about this a little bit yesterday. Think about it for a minute. Well, I probably wouldn't use cosecant because cosecant would involve the hypotenuse. I want to use the information that's been given. So I'm going to use these two sides, and these are not the hypotenuses. These would be opposite and adjacent. So I won't be using cosecant. I would probably be using what function? Tangent. And depending on which angle I was looking at first, if I'm looking at angle F, the tangent of angle F would equal what? 11 over 10? I need to find an angle. I told you yesterday, I only mentioned it one time, but if I want to find an angle on my calculator, what button do I press? Second tangent. In order to find the angle, when you want to find an angle, you press second tangent. Angle F is going to be the angle whose tangent is 11/10. So here we go. The angle whose tangent is 11/10 is 47.73 degrees. Anybody else get that? Now, do you understand why I picked tangent? Because sine or cosine would have involved this rounded off number, right? So I might as well just go with the whole numbers. It's just easier. Now tell me about angle E. Yeah, these two, all of them have to add up to 180, or these two have to add up to 90. So I'll just subtract 90 from that, or that from 90. And 42.27. How do you feel about that? Okay? All right. Then let's try this, because quite honestly, kids, you're not just going to be walking down the street and have a triangle fall out of the sky and say, solve me. That isn't the way it really happens. This is what happens. Find the height of a tree. If a squirrel at the top spots an acorn on the ground 15 feet from the base of the tree with an angle of depression of, let's say, 13 degrees, 12 minutes. All right. Let's draw a picture of this scenario. Here's the tree, here's the ground. Here's the squirrel. Here's the acorn. squirrel looking at acorn. Now, we get to assume the tree is vertical. That's the assumption we make. If we had a tower and we were looking up at the top of a tower, we would assume the tower was vertical. So we're going to assume a right angle there. What do I know? This is 15 because the problem tells me that the acorn is 15 feet from the base of the tree. I also know this is what I'm looking for, right? That's the height of the tree. That's what I'm looking for, the height of the tree. Someplace I have to put a 13 degrees, 12 minutes. Where am I going to put that? Here? No. An angle of depression or an angle of elevation, either one, is always measured with the horizontal. So if I'm the squirrel looking straight out, my angle of depression is how I tilt my head to look down. It starts straight ahead. So you always measure your angles against the horizontal. This is the angle of depression. Now, interestingly enough, and this will always be the case, what if there were a worm in the acorn looking up at the squirrel? This would be his angle of elevation because that's measured with the horizontal, right? What can you tell me about that angle? It's the same, again, because of geometry. What are these called? Alternate interior angles. You've got two parallel lines cut by a transversal. Those are alternate interior angles. It will always be, kids, that the angle of depression will match the angle of elevation. Always. So when I draw this picture, I don't even mess with that one. I just put this one down here because that one's not even in the triangle. So I just put it down here. They'll always match. Okay, so now we got to find x. So your one and only question that you ask yourself is, which function do I use? Sine, cosine, or tangent? I would never use the other three because they're not on my calculator. So stick with sine, cosine, and tangent. Which one do you think? Why tangent? Because it's opposite and adjacent. Very good. So we'll say tan 1312 equals x over 15. So x equals 15 tan 1312. So my calculator's still set in degrees from before. 15 tan 13. Gotta get my degree mark, my minute mark. This is a pretty short little tree. Did you get 3.5?
Yeah.
Tiny little tree. Sort of like my Christmas tree. He's in a bush, yeah. Forget the trees in a bush. All right, let's try one more and then we'll be done. You can start your homework. A sailor on a ship. 3,000 feet from the base of a cliff. Spots an eagle on the top of the cliff. Find his angle of elevation if he is 1 mile from the eagle. Geez, I love trigonometry, don't you? Oh, she does? What did you wanna ask me,
I was
Jessica?
wondering if we could do Secret Santa.
I'm fine with it, if everybody else is fine with it. I think it's a great idea. If, I don't know how the rest of the class feels about it. I'm fine with it, I think it'd be great, first period,
Like
everybody
sound
gone.
changes.
Would we have like a limit, like $5 or something?
Yeah.
It's one more added stressor, but do you think you're up for it?
Receive. Sure.
Yeah.
That's something.
So, do you want to be the organizer of it, Jessica?
I can probably do that.
Okay. And so will we like draw names tomorrow or something?
Yes.
Okay, I think that would be good. And then we'll, maybe on the review day, is that the day you want to, actually do it then? Okay, except some of you won't be here.
We could do it the next one.
We could do it next Friday? Maybe we'll shoot for that next Friday, since we'll have all of our kids here then. Okay? Great idea. Okay, good. All right, now, have you drawn a picture, though, of this situation? Here's the cliff. This is the eagle. Here's the eagle. Here's the sailor. We're assuming the cliff is vertical with the ocean. This is the ocean. That's the ship. Now tell me what I know about that and what I am looking for.
3,000.
Where does the 3,000 go? Right here. It says from the base of the cliff, so this is 3,000. I'm finding this angle right here. This would be the sailor's angle of elevation. Would you agree? If the eagle is looking at the sailor, this would be his angle of depression. Now, what do I do with this mile? That would be 5,280 feet, right? If I'm going to use 3,000 feet, I have to use feet here. And that's the hypotenuse. It says the sailor is 5,280 feet from the eagle. That is 5,280 feet. Now I need to find that angle. What function am I going to use? Cosine. And I will say the cosine of that angle equals 3,000 over 5,280. Would you agree with that? Now, how do I get an angle? I'm looking for an angle. What buttons do I have to press? I have to press second cosine. My angle will equal second cosine 3,000 over 5,280. It's second cosine because you're working backwards. You've got the cosine, you're working backwards to the angle, so you're inverse cosining. And that works out to be 55.38 degrees.
To do this, does it have to be in the angle mode, or no?
Degree?
Degree mode?
It doesn't, but we're most comfortable with degrees, and so that's why I just left it in degrees. You could certainly answer that in radians, and if you did, I mean, you would say, like, my answer is 55.38 degrees. If you answered in radians, your answer would be whatever radians. It's okay, that would be okay. All right, everybody okay with that? Okay, put into your planners then, for our Secret Santa a week from tomorrow. We'll draw names tomorrow. Jessica, do you want me to provide you with the list of names?